Let's take some time to talk about mirrors. We'll have done this in class, hopefully, but if you want to come back and review, you've got this as a video to kind of walk through the parts of that model. So in the mirror model, our first model statement is that a mirror creates a virtual world that is an exact copy of the real world. Now, it's not actually creating it, and this is a good example of a place where a model is maybe not 100% truthful, but it's still really useful. So the mirror is not actually making anything, but this is an easier thing to maybe wrap our brains around than trying to imagine light bouncing and trying to figure out all of that bouncing and where should it be, and doing a lot of math. Instead, we can just imagine it's creating a virtual world that's an exact copy of everything in the real world. And those duplicates exist at the same distance from the mirror, but on the opposite side. So if I've got a mirror here, and I've got a triangle up here, well, I'm going to get a triangle that's the same distance on the opposite side. If I've got a circle right here, I'm going to get a circle right here. If I've got a square up here, I'll get a square here. So everything's getting replicated, just same distance, opposite side. Model statement 2 is that mirror then is functioning as a window into the virtual world. So in other words, there's no reflection happening, we're pretending, we're just imagining straight lines through that window. So something can be seen if a straight line can be drawn from the object to whatever's trying to see it, and if that line goes through the window or through the mirror. And so this also kind of swinging back to real and virtual, anything that can be seen kind of inside the mirror is by definition a virtual image, right? If you reach on the other side of the mirror or try to go back behind it or try to go through the mirror, you're not going to be able to interact with those images. And the reason why this happens is because they are reflecting the rays that strike them. So light is going to bounce off the mirror and hit our eyes, but our eyes think that it came from a straight line, so it goes in a straight line back until it goes as far back in the mirror as it was on our side. And so this is what's happening with mirrors. So this will help a lot with flat mirrors, but it doesn't work for curved mirrors, because curved mirrors create a distorted virtual world. And so things might appear to be closer or farther from the mirror in the virtual world than they are in the real world. So we can't use those to do it. And that's a place where this model does have its limits. The technical, precise, exact explanation will be able to be used for both curved and flat mirrors, but since most of what we interact with are flat mirrors, this model ends up being really useful.